Hello, today I gonna present about midterm project of robot operation simulation and uh, my type is pick and place presented by Miss.Niratsanee Khonthongoen. Please listen. Um, okay, the first one I gonna show you about product specification to IRB 120 and uh, is there six axis: axis 1, axis 2, axis 3, axis 4, axis 5, and axis 6 to rotate around the area. Okay, and dimension about IRB 120 is position A. This one it can be minimum turning radius axis 1 and radius equal 121 millimeter, and the part B is can be minimum turning radius axis 3 and radius equal 147 millimeter, and the part C minimum turning radius axis 4 radius equal 70 millimeter. Okay, and next I show you about product specification about IRB 120. The IRB 120 is available in two versions, and both can be mounted on floor, invert, or on wall in any angle around X or Y axis, something like that. And so actually robot type IRB 120 handling capacity is 3 kilogram and reach 0.58 meter. Okay, and manipulator weight. The data about IRB 120, the weight is 25 kilogram, and power consumption part E1, E2, E3, E4 in the ISO cube maximum load. The type of movement ISO cube maximum velocity is power consumption is 0.24 kilowatt, and robot in 0-degree position about IRB 120. The bracket engaged can be 0.095 kilowatt, and bracket disengaged it can be 0.173 kilowatt. In mounting the manipulator maximum load in relation to the base coordinate system, the floor mount for xy is plus minus to 265 Newton on endurance load, and the maximum load is plus minus 515 Newton. And for C, subtract 265 or plus and subtract 200 Newton. And maximum load minus 265 and plus and minus 365 Newton. And torque xy is can be plus and minus 195 Newton meter. And the maximum load plus and minus 400 Newton meter for maximum load. And torque C plus and minus 85 Newton meter. And about maximum load is can be plus and minus 155 Newton meter. And wall mount force xy can be plus and minus 470 Newton for endurance load. And for maximum load is plus and minus 735 Newton. And for C 0 plus minus 200 Newton for endurance load and plus minus 450 Newton meter for maximum load. And torque C plus and minus 90 Newton meter for endurance load and plus and minus 175 Newton meter for max load. And suspended force xy is plus and minus 265 Newton for endurance load and plus and minus for 515 Newton for maximum load. Force C 265 and plus and minus 200 Newton for endurance load. And for maximum load is 265 and plus and minus 365 Newton. Torque xy plus and minus 195 Newton meter for endurance load and plus and minus 400 Newton meter for maximum load. In torque Z plus and minus 85 Newton meter for endurance load and plus and minus 155 Newton meter for maximum load. Okay, next, ambient temperature. Okay, it's about manipulator during operation. Protection class is PB standard and temperature is 5 Celsius to 45 Celsius and manipulator with food grade verification during operation. Protection class on option and temperature is 5 Celsius to 35 Celsius. And for the controller standard and option, temperature is product specification and controller IRC5 with brake pendant and complete robot during transportation. and store it um, on standard. The temperature is minus 25 Celsius to past 55 Celsius, and for short periods on standard protection class, the temperature is up to past 70 Celsius. And bridge torque, the IRB 120, the max bridge torque axis 4 and 5 is 4.8 Newton meter, and max bridge torque axis 6 is 2.2 Newton meter, and max torque valid at load is 3 kg. And working range, the position, I separate something like that, and the first one is position A. The position A, this one, the position A, the position at the ridge center x-axis is 302 millimeter, Z 630 millimeter, and angle degree x2 0 radius and x3 0 radius. And position B is this one, position 2. Also, the X position is 0 millimeter, and C position is 870 millimeter, and angle is 0 degree and minus 77 on x3. And the position C is position 3 on the picture. The X position is 169 millimeter, and position C is 300 millimeter. On angle x2 is 0 degree, and x3 is past 70 degree. On position D is this one on the picture, and the X position is 580 millimeter, and C position is 260 millimeter, and angle on x2 is past 60 degree, and on x3 is minus 77 degree. And about position E, the position E is okay, this one. The position X, it is 545 millimeter, and the position C is 91 millimeter, and on angle x2 is plus 110 degree, and x3 is minus 77 degree. Position F is this one on the picture. If the position x is minus 440 millimeter and position C is minus 50 millimeter, angle axis 2 is minus 110 degree and axis 3 also. And the position G is this one. The position X is minus 67 millimeter and position C is 445 millimeter. And angle on axis 2 is minus 110 degree and axis 3 is plus 70 degree. About position H on this one. The position X is minus 580 millimeter and position C is 270 millimeter. And angle on axis 2 is minus 90 degree and axis 3 is minus 77 degree. And the position J. Okay, I think this one. The position X is minus 545 millimeter and position C is 91 millimeter and angle on axis 2 is minus 110 degree and on axis 3 is minus 77 degree. The robot motion, the table specifies the type and range of the motion in every axis. The location of motion, type of motion, range of movement. Okay, let's go. The axis 1, the type of motion is rotation motion and range of movement is plus 165 degree to minus 165. And axis 2, type of motion is arm motion and range of movement is plus 110 degree to minus 110 degree. And axis 3, the type of motion is arm motion and range of movement is plus 70 to minus 110 degree. Axis 4, type of motion is wrist motion and range of motion is plus 160 degree to minus 160 degree. And axis 5, type of motion is bend motion. Range of movement is plus 120 degree to minus 120 degree. And axis 6, type of motion is turn motion and range of movement is plus 400 degree to minus 400 degree. Okay, and is the default and can be plus 242 revolution to minus 242 revolution maximum. Okay, the next is the set of the tune and coordinate system. the first one, I open the program Robot Studio, the new project, and I create my name and location for my file, and select the type of robot. Okay, I select IRB 120 for 3 kilogram and 0.58 meter, and create it. Okay, and next I click the mouse, right click and select position and set position, and the position C, I create the number is 600 to move up, and you can see on the picture. And I create the solid, I select solid box and create a length, wide and high, and the position look like this, and create it. Okay, and part I part of solid I rename and change box. Okay, and I right click and select modify, set color, and select the color if you want, and select OK. Okay, and next step I show you about the object on the arm robot. I select vacuum suction cup to IRB 120 on the ABB app, and this one is vacuum suction cup. It is Ventosa, and I rename about it. Okay, and the next I drag the G1 on IRB 120 3 48 and 01 on this one. Okay, something like that. And the program show the question for update the position of G1, and you select yes. It can be look like this on the arm of ABB robot. And the next I select import library and select equipment and select conveyor, and Y is 400 millimeter, and select OK. Re your name. Okay, look like this. And the next I'm set the position of conveyor 1, look like this, and set the position at okay, and the first one you add the conveyor to on the equipment on import library as well. and apply it and close. Okay, and next I create the solid on the conveyor. The length is 200 and height 30 and create the before you create it, you must to set the position of the box on this position and rename. Okay. Okay, and next I create the target to mark the point for uh, robot movement. Okay, then the first one I select target icon and select create target, and the program show you some information to make sure the change this value and click OK. Okay, and next I modify the target. I select off and the target appear on the program. You uh, click on this point and create it, and the program show you uh, look like this. It is the coordinate of the target 10 or target 1. And I created solid again on the conveyor to I set the length some area for the box and set the position on the conveyor, and I create the target on the solid. And then I right click the target on T underscore R O B I and select this one, the target one, and right click modify target, select rotate. Okay, and the program show the window look like this, and you select this one and you the program show some information to ask you and click yes, and then you move the position on the blue line on ABB robot and select teach instruction. Okay. Okay, I forgot to recommend you to create the part and procedures to create the part, and the next I'm click click the part to run the program, run the process, and next okay, and next I right click again and select set as simulation entry point. Okay, and then on the active simulation, the simulation configuration, I select all. Okay, and close and for pray for simulation and show some station logic to uh, control the robot. You click station logic and select add component and select sensor and use collision sensor, architecture, detector, sync, or something like that to correlate your code and select station logic again and right click, select new vertical tab group. Okay, and next select move L on the target 1, right click, select modify instruction, select zone and file to easier for find the object. And then on the station logic, the first one is collision sensor. Okay, the object one is G1. G1 is it is the suction cup, and object 2 is object on the conveyor one, and the near miss must be 5 millimeter. And you drag the sensor out to execute on the architecture. And next on architecture, the property of the object 1 is the F1. F1 is the object on the conveyor 1, and object 2 is uh, the object on the conveyor 2, and put some number of near miss is 3 millimeter. Okay, and then click apply. And the move out on the target 2, you right click and select modify instruction, select zone and select file to the easier for easier to find the object. Okay, and datacher property is select the F1 is the object on the conveyor 1 and apply again. The logic design with the station logic is look like that. I show you about the collision sensor is the pick the object and attach texture and the suction the object, and the collision sensor to move to sensors 2 and curve it to the place, release the object on the conveyor too, something like that. And you drag the sensor out to execute on attacher object 1 to parent on attacher and object 2 F1 and drag to child for the attacher. In the collision sensor 2, you drag the sensor out to execute on the detector 2. It is the logic of the controller. And then I synchronize. I select all and click OK. In the process, it show you about some the line, yellow line for move the target 1 to the target 2 and repeat again. And I create a TCP trace. I select enable TCP trace and select the color. I choose the blue color and click OK. And it show you some the blue line on the conveyor on the process. Okay, and the result of the TCP trace is look like it and show some the way for the robot ABB robot movement. Okay, and this one is the module of the IRB 120. Show some target 1, target 2, targets for move the sequence of movement. And this one is the position and the sequence for movement also. Also, I will show you some module independent and show some the position and sequence of movement in the ABB robot. Okay, you can click the controller and click enable and run the program like mm, jogging, something like that. And I recommend you to use the teach instruction for easier to create the position. Okay, and run the module in the flight pendant. Okay, I tell you we're already on the before slide, the period slide. Okay, look like this. Show some move L target 1, move L target 4, move L target 3, move out target 2, move out target 3, move out target 4, move out target 1, and if the process run away and um, 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 show you repeat and repeat again. And the next is the signal analyzer. Okay, the signal analyzer, it show you some the auto scale, snap to point, show the guide and show the point to on simulation. Look like this. Show some the straight line, the vertical line, the the, the rectangle, and some the uh, the step position, the step line, and the curve line. Look like this. And look like this as well. Show some the input, show some the logic 1, 1, 1, logic 0. And next is stopwatch to count counting the time of the process. And I count the process from the conveyor 1 to the conveyor 2. The total time is 2.664 to run the process. And this is the result of the ABB robot pick and paste of my project. And the recording playback show you some video recording, show some playback, record simulation, record application, and record graphic. Look like this. And this is the video for simulation. Okay, and this is my project, the robot ABB robot pick and place, and I will show some the process, the simulation of process, and wait for working. And my work show you some look like this. Move the object from the conveyor 1 to the conveyor 2, and the robot will detect the object, and it suction the object and pick the object, and then move to the position to release the object again. I make some the the process run again and again. Okay, something like that. And show you some layout, attach, reveal, signal analyzer. Show you look at this, and stopwatch. Oh, sorry, some error. Okay, thank you for listening my presentation today, and have a nice day. Thank you.